Hello everyone, my name is SP Sajjan from Ranichanam University, Belgaum, India. This is a brief overview about our research, restoration of ancient Kannada handwritten family manuscript using image enhancement techniques. Topics to be covered: introduction, literature survey, proposed method, result and discussion, and conclusions. In the recent days, the research area of handwritten character recognition got much attention towards ancient inscriptions because since they contain lots of unfound knowledge in the field of science, literature, astronomy, medicine, etc. The materials used to write these inscriptions are papers, palm leaves, stone rocks, and temple walls, etc. These materials are now degrading in nature due to climatic conditions, ink bleeding, lack of attention, and unscientific storage. So our aim is to digitize and restore these ancient inscriptions because it has lots of knowledge. That's why in this paper the digitization and the restoration of Kannada handwritten palm leaf with the iterative global threshold based techniques is developed. The performance evaluation is done by calculating MS and PSNR value. The quality of the image is compared with manual results obtained by Afik Rapids. The results is also compared with the other standard methods like namely Salvia, Niblack, and adaptive thresholding. So adaptive thresholding, in this algorithm we have used Gaussian plus binary inverse combination. We are used as adaptive thresholding algorithm. The comparison studies confirms that the proposed method is more effective than the other methods. The proposed method is also implemented on the benchmark standard palm leaf dataset, that is MOD Lontari set. This is one of the benchmark dataset in palm leaf. In the literature, very few of them contributed in this area, especially for ancient inscriptions in Kannada. Especially image enhancement technique were used to restore degraded Kannada handwritten paper inscriptions has been proposed by Parsuram Banigidar and Chandrasekhar Gidar. Image of degraded non-uniformly illuminated historical Kannada handwritten documents were restored has been proposed by Parsuram Banigidar and Chandrasekhar Gidar. These two are worked especially from Kannada inscriptions. But another is cleaning of old document images with a modified iterative global threshold was developed N. Venkat Rao with all. The performance of a novel historical document restoration algorithm using Solvay thresholding and a hybrid method of both some local filters has been evaluated by described by Neha Kundal and Anantadipa. The global thresholding specifies the global values of all the images pixels intensities in order to distinguish them as text object and background proposed by Enosto. There are many papers literature I have found, but some of them are very important. I have listed here. Proposed method. The iterative global threshold algorithm is developed. The global threshold defines a global value of all the pixel intensities of the image in order to separate them text object or background. The relative closeness towards background intensities is computed in each iteration after image equalization. This technique can handle various degraded conditions in each iteration. The intermediate tone shifted towards background, thereby providing efficient distinction between foreground and background. In this global thresholding, it works iteratively, so separate them and means foreground and background every time based on threshold value. It is takes to either 0 or 1. The iterative global threshold also algorithm is also implemented with MND Lontari set, a benchmark palm leaf data set. The iterative global threshold with the PSNR gives a better result as compared with the traditional thresholding algorithms, as compare other traditional algorithms. The proposed algorithm split into two parts. First part is iterative global threshold, means what in this first algorithm we are finding iterative global threshold with these steps. And second algorithm, calculating average pixel values. Here we are giving palm leaf image, we'll get a background image we'll get in first algorithm. So applying iterative global threshold to the palm leaf image, converting image to numpy array, calculating mean value of all the pixels as a threshold, subtract threshold from pixel in numpy array with 1 minus thresholding plus np array np image. Make it histogram equalization. If the number of the pixels transferred between two iterations less than 3%, then we terminate, else it's continue. If the pixel is not already background, then convert it to foreground. So this is a simple algorithm in first algorithm. Second one, we are converting palm leaf image, the final image with a binarized image will get, subtracting ti from ti minus 1. Actually in the formula, if a numpy array is equal to 1 minus thresholding plus np image, the grayscale histogram is structured to distribute the remaining pixels across the grayscale. So we are finding minimum pixel values with the np image. So divide we will get 1 minus np image divided by 1 minus minimum pixel values. Repeat this step 1 to 3 until the termination condition is fulfilled. The ultimate image is binarized image with the value of MSC and PSNR for font evaluation. For this we have used for Python 2.9 Anaconda with the Jupyter Notebook. So proposed method for flowchart explanation. Here iterative global threshold value can be computed repeatedly. The proposed method comprises the various steps which are presented in the flow diagram. In first step, we are giving original camera captured palm leaf image converted into grayscale image, applying a global thresholding technique. In fourth step, it will applying, you are finding calculating intensity values in 4 and 5 steps, calculating intensity values from ith iterations with the histogram calculations. In these two steps, histogram calculations with the intensity values ith iterations. So based on peak value of histogram is chosen as threshold value. This value is used to separate foreground and background. Based on fifth step, histogram peak value that where considered as peak value is used to separate foreground and background. That is segmentation value. Now initialize, now start with the iterative global threshold. Initialize z is equal to 1, calculating the values of z like ith iterations. If z is equal to 1, actually initially z is equal to 1, if greater than 1 it will move to step number 10, if equal to 1 or less than 1 go to step number 11. Now actually if z is equal to 1, then tz calculating first time, because now it is z is equal to 1, it is the first time, there is no value of tz minus 1, so it will move to step number 11 and go to step number 12, z increment by 1. If z greater than 1, then move to tz. And now in this step we are in 10th step comparing tz and tz minus 1. If tz value is alpha times greater than tz minus 1, then go back, then this is tz value is alpha times greater than tz minus 1, then go back 11th step, and 12th step it is repeats up to until the condition is reached. When it is false, the flowchart will be finished. Come to the 13th step. Alpha is the used to decision making in this algorithm. Here alpha less than 1, then we got true positive values. Alpha is greater than or equal to 1.5, you will get false positive rate. Alpha is equal to 1.1, optimal value of the alpha value to make it decision. This is simple explanation about this proposed method flowchart. Then resultant discussions. In this, the original historical Kannada handwritten palm leaf camera captured image are shown in figure number 3. This is your first image. It is shown in figure number 3. This is camera captured original palm leaf image. A typically noise document in present in figure number A having non-uniformly distributed noise. The background of the noisy image is golden brown in color. This is A is explained here. The computed histogram of the original noisy document is shown in figure B. This is histogram of figure A, original palm leaf document image histogram. Then compare the result with our method, that with Solvia, NeBlack and adaptive threshold, which are illustrated in figure number C, D, E. This is Solvia, NeBlack and adaptive thresholding. This is our proposed method result shown in figure number F. So clearly shows that figure number A as compared with the figure number F, it is clear as compared with A and F. Though this also implemented, this is a original palm leaf image to get better result as this in this experiment. This is also we have implemented with the standard data set MD Lontari set. This is proposed by MWA Man, and his team is developed and publicly made it publicly available for benchmark palm leaf data set. We have our algorithm also tested with this benchmark data set. In this figure shows, in this result shows a typically noisy document MD Lontari set dataset image number figure number A, and ground truth image of MD Lontari set image dataset. This is ground truth image, and we have applied thresholding, adaptive thresholding algorithm. We got algorithm with figure A, we got this result. So our proposed method means IGT algorithm applied with the figure A, we got this figure number D. This figure number D clearly shows that this is near to the ground truth image. It is as compare with figure number A to figure number D, our experiment is clearly shows that we got a better result as compare standard methods also. So this in this table shows that I have explained, we have done with the iterative list of experiments, NeBlack method and Solvia and adaptive proposed method. Here in NeBlack method clearly shows that average value is 4.464 and MSC value 0.23, and Solvia method 5.18 and 0.30, and adaptive thresholding 5.87 and 0.306, and our proposed method got 6.198 and 0.23. In the literature, higher the PSNR and lower the MSU considers the accuracy of the result and best result. So in our proposed method gives the better result as compared with the traditional algorithms or basic like NeBlack, Solvia, adaptive threshold algorithms. So this is about our some experiment results shown in this table. So graphically representation of our experiment, this is clearly shows that in graphically here NeBlack method and it is increasing order. Our proposed method is better result in PSNR, higher the PSNR value as compare previous three, and lower the MSC value. This shows that our experiment is better as compare traditional algorithms. So now the conclusion, the result will be obtained from the present study are expected to be more relevant and significant to the development of appropriate software tools that aids to epigraphists, historians and archaeologists by enabling them to us historical Kannada handwritten script recognition. Means what, this is our result is helps to development of software tool. It helps to historians, epigraphists and archaeologists to understand ancient history and culture customs. We can easily understand previous our history and culture. That's why The digitization and restoration of Kannada handwritten palm leaf manuscript have been significant role understanding the ancient history and culture customs. This also helps to understand the identifying the age of the palm leaf. The promising results are achieved as compared to the other standard methods, namely salvia, knee black, and adaptive thresholding in the literature. The iterative global thresholding removes non-uniform illuminated background noise, and better accuracy is obtained in the proposed attempt. The proposed algorithm is also being tested and implemented on the standard palm leaf benchmark dataset such as Amedi Luntari set dataset and got a good result. Further, the classification and recognition of the Kannada handwritten manuscript written on palm leaf will be considered in the future work. So these are the some references I have referred in this research. Only there are so many other papers also have referred, but these are the some of the important references I have referred in this list. Thank you being a part of EAI conference. Thank you one and all.